Lesson 8.2, and be sure to include today's date. Okay, here we go. Let's jump right into this. Now first, let's take a look at what a logarithm looks like and how to correctly read one. Okay, please copy these examples down. This is a logarithmic expression right here. This is a logarithmic function, and actually, let's make this a 5, an x right here, okay? This should be an x. Alright, so this is a logarithmic expression. Obviously, it's an equal sign here. No x's and y's. This is a logarithmic function. Here's your y, and here's your x. Please copy these down. These are what logarithms look like. Please copy this down. Now, it's very important you know how to read these, okay? So please copy this down. I want you to look intelligent when you work problems like this later. There's two different ways to read this expression, okay? Now I'm going to go fast, so you'll probably have to pause the video, which is fine, but there's two ways to say this expression right here. You can say log base 2, because this little number right here is your base. Log base 2 of 4. You're taking the logarithm of 4. So log base 2 of 4 equals 2. That's one way to do it. I'm not sure why I didn't write out the word there. I guess I should have, to be consistent. Okay, so that's one way to say it. Log base 2 of 4 equals 2. Another way to say it would be log of 4 with base 2. Log of 4, you're taking the logarithm of 4 with base 2 equals 2. Log of 4 with base 2 equals 2. So make sure you understand how to say these correctly. That's really, really, really important. Okay? Now, this would be said pretty much similar the same way. Alright? And remember, I wanted to change this to an x. And so everywhere you see the word 5, there should be an x. Now copy these down, and I'm going to move on. You would say y equals 2 times the log with base 2, or log base 2 of x plus 4. Isn't that, guys, isn't it simple? You're just reading it left to right like it's a book. Y equals 2. The 2's next to the log, so obviously they're multiplying, okay? Y equals 2 times the log base 2 of x plus 4. Or, if you want to say it this way, that would be fine. You could say y equals 2 times the log of x with base 2 plus 4. Y equals 2 times the log of x with base 2 plus 4. So you can either say these log of 4 with base 2 or log base 2 of 4. You can say log of x with base 2, or you can say log base 2 of x. Either way, this is your base right here, the little number. Okay, now, whatever you're taking the logarithm of, please write this in your notes. I should have typed this for you. Write this in your notes. Whatever you're taking the logarithm of, that's called your argument. So this 4 right here is called your argument. This x right here is called your argument. This 2 right here is called your base. This 2 right here is called your base. Okay? Now this number here has no name. This has no name, okay? But the two things I want you to see here, the two parts I want you to understand is the base and the argument. So you take the log base 2 of 4, or log of 4 with base 2. Over here is the log of x with base 2, or log base 2 of x. Either way, you're taking the logarithm of x or the logarithm of 4, and your base is 2, and your base is 2. Now, it's a coincidence that both of your bases here are 2. Okay, your bases can be different numbers, alright? So understand all of this. Now let's continue on. Okay, now moving on. Next, you need to understand what a logarithm is. I mean, all that I've done so far is showed you what they look like and how to to Sam, you have no idea what a logarithm is or what it does for you. Okay, so please copy this down. A logarithm is simply another way or form of writing an exponential expression. So yesterday we were looking at exponential expressions. Today we're looking at another way to write them. So copy this down, please. A logarithm is simply another way of writing an exponential expression, or it's another form of an exponential equation or expression. Excuse me. Exponential expression. While you're copying that down, let me ramble. This would be an exponential expression right here. 4 squared equals 16. That's an exponential expression. Well, you can rewrite that using logarithms. So a logarithm is simply another way of taking an exponential expression and rewriting it. Let me say that again. A logarithm is simply taking an exponential expression and rewriting it in another form. It's that simple. That's all that a logarithm is. Let me show you what I mean, okay? Please take some really good notes on this. Watch. See this logarithm right here? Let's practice saying it. Log base 3 of 9 equals 2, or log of 9 with base 3 equals 2. Well, did you know this can be rewritten like this? You can rewrite that as 9 equals 3 to the second power. There you go. Now I'm gonna teach you how to do that in just a couple seconds, okay? But my point is this logarithm here equals this right here. So you took an exponential expression and you rewrote it logarithmically. Now, once again, don't freak out and wonder where this came from. I will teach you that in just a second. But what I want you to understand right now is that a logarithmic expression is simply another way of writing an exponential expression. That's all that it is. So the first thing we need to do now is you need to be able to write exponentials logarithmically like this. I give you this and you write it like this. Or you have to know how to write logarithms exponentially. In other words, I give you a logarithm like this and you write it like this. So in other words, you should be able to go back and forth. If I give you this, you can write this. If I give you this, you can write this. Okay? So the first thing you need to be able to do is to write these exponentials logarithmically and write your logarithms exponentially. Alright? So here is the model you will need to use. Memorize this. Learn it. Know it. This is the foundation for logarithms right here. This is so important. Log base A of B equals C is the same thing as B equals A to the C power. Are you watching? Whatever your base is becomes a base over here. Whatever your argument is goes right here all by itself. And whatever is over here on the right side of the equal sign becomes your exponent. And that's it. Do you not see that you're just memorizing where to shift letters around or numbers depending on the problem? So, and by the way, this right here can also be written like this. You could say A to the C equals B, right? I mean, it doesn't matter which side of the equal sign the B is on or the A is on. That doesn't matter. But remember, whatever your base is in the logarithm is always your base over here of the exponent. And whatever your argument is always all by itself. Always. And whatever the logarithm equals C, that's going to be your exponent. Guys, look at this. Go over it. Memorize it. You must know this like the back of your hand. You must be able to quickly go from logarithmic to exponential or from exponential to logarithmic expressions. Okay, that's very important. Let's practice converting these. Let's first of all start off with 4 logarithmic expressions, and I want you to write them exponentially. Okay, so here we go. If I go too fast, pause the video. Here's the first problem. I want you to write this exponentially. Here we go. Well, first of all, whatever your base is stays a base, right? Look up here. Here's your A. Here's your A. Whatever the logarithm equals, the logarithm equals what? 5. That's always your exponent. And your argument is always all by itself. That easy. So the base always is the base here. Whatever the logarithm equals is always your exponent, and your argument is always all by itself over here. Let's try another one, okay? First of all, your argument is always all by itself. Notice how I'm putting them on different sides. I want you to get used to seeing this both ways. I mean, see this right over here, guys. See this? You could have also written it 1024 equals 4 to the 5th. It doesn't matter which side this is on or which side this is on. It's not a big deal, okay? So, my argument always goes by itself. My base of the logarithm is the base of the exponent. And whatever the logarithm equaled what? -1. That is your exponent right here. Let's try another one. Here is a logarithmic expression. By the way, this expression here equals this expression here. This expression here equals these expressions here. They're all the same. Now, let's write this logarithmic expression exponentially. Are you ready? Here we go. Whatever your base is, stays a base. Whatever the logarithm equals, in this case it equals 3, that is your power, or your exponent. And then your argument, which is 512, that's what you're taking the logarithm of, goes by itself over here. So there we go. This expression here equals this expression here. They're the same. And then lastly, let's do one more. Log base x of 5 equals 3. Log base x of 5 equals 3, okay? Your argument always goes by itself. Your base is always the base over here, and whatever the logarithm equaled, that is your exponent. And there we go. Guys, are you getting this? It is so important. You can take a logarithmic expression and write it exponentially. Now, let's go backwards. Now I'm going to go like this. They're all going to disappear. So, if you're not done copying these, pause the video, okay? Now let's go backwards. I'm going to give you some exponential expressions. You're going to write them logarithmically. Are you ready? Let's go backwards now. Okay, 1/6. See it right here. Remember, whatever is all by itself is the argument. Okay, here's b. See that? And that's your argument, b. So I know I'm going to have log of 1/6. Now, here's the base of my exponent. Here's my exponent. Here's the base. The base of my exponent is the base of my logarithm. Remember? And the exponent is always all by itself. That's what the logarithm equals. There it is. And if you think I got this wrong, we'll just quickly write this. Take this and write it exponentially. The argument is all by itself. The base is a base. And whatever the logarithm equals is your exponent. And booyah, that's exactly what I have right here. Okay? So follow this along. You're just following A's and B's, okay? A's and B's. Take a look at this one. 144 equals 12 squared. See it? Maybe I should put some B's for you here, okay? Here's your base, so that's your A. See it? A. Here's your exponent, so that's your C. And this is your B. So now write your logarithmic expression. You have log. And then base A. What's A? 12. Next is B. What's B? 144. And then what's next? Equals C. C is 2. So equals 2. The number by itself is your argument. The base of your exponent is the base of your logarithm, and your exponent is what the logarithm equals. Okay? Go back and do these again if you're confused. You've got to be able to do this totally on your own, logarithmic to exponential, and you've got to be able to do these totally on your own, exponential to logarithmic. Okay, let's take a look at this one now. I'm going to write the word log, okay? Now, here's my base, right? So there's my base. Here's what's all by itself. That's going to be my argument. And then here's the exponent. That's going to go over here on the right side. Let's try another one. Let's write the log here, log. Now, here's the base of your exponent. So I'll have a base right here. And then this is what the exponent, the exponential expression equals. So that's what I'm taking the logarithm of. And then my exponent is 2, and that's all by itself over here. And there we go. Students, please understand how important it is to be able to write expressions exponentially, from exponential to logarithm, and from logarithm to exponential. Very, very, very important, okay? Alright, let's continue on. Now let's take this newly acquired knowledge and let's apply it to some problems, okay? Here they are. Let's solve these logarithms without using a calculator. Alright, here we go. 4 problems and we're finished, so not a super long video, okay? I want to make sure you guys understand this. Take our time and make sure you really understand it. Now, let's solve this logarithm. Now, I've never taught you how to do this, so please pay attention. The first thing you do is you say to yourself, okay, I don't know what it equals, so I'm going to say it equals what? X. That's simple, isn't it? So I have no idea what this logarithm equals, so I'm going to say it equals X. Now, next thing you do is you write this exponentially. So, here's my base, 3. Here's what the logarithm equals, that's my exponent. And then my argument goes over here by itself. Now, we've got to solve. I'm going to scoot some of this up to get some room here. Now, we have to solve for X. Learn to be creative. Are you listening, guys? Watch this. If I had 3 to the X power, don't write this down, just watch, and I had 3 to the 5th power, would it not be easy to see what X equals? X has to equal what? 5. Because if I have a 3 and a 3 and a 5 here, then in order for these two sides to be equal, this X has to be a what? 5. 3 to the 5th equals 3 to the 5th. Do you see that okay? Now the reason that's so easy to see is you have like bases. You have a base of 3 and a base of 3. So your goal when you're solving this exponential expression right here is to write both sides with the same power or the same exponent. Well, I can write 81. What's my base over here? 3. Can I write 81 with a base of 3? Sure you can. Think about it, guys. What's 3 times 3? 9 times 3? 27 times 3? 81. 3 times 3 times 3 times 3 is 81. So 81 is the exact same thing as 3 to the what power? 4th, isn't it? I mean, sure it is. And now look, what does X have to equal? 4. And believe it or not, some of you are seeing this, but some students actually struggle seeing that X equals 4, even though the problem is written like this right here. So what I say is this: if your bases match, feel free to cross them off and set the exponents equal. That's fine too. There you go, X equals 4. Okay, there you go, guys. So let's review. If you don't know how to solve a logarithmic expression, you admit that you don't know and you set it equal to X. Then you write a logarithm exponentially and then solve the exponential problem. Let's try another one, okay? Alright, here we go. We're going to solve this logarithm without using a calculator. So we're going to say we don't know what it equals, so we're going to give it a name. We're going to call it X. It equals X. Next, we're going to write it exponentially. So, remember your argument is always by itself. And the base is always the base. And then this goes up top right here. Alright? Now, this looks really, really difficult. because we're going to have to somehow write these sides with the same base. Now this one, even though you might not have thought to do it on your own the first time, after I showed you it's pretty easy to see 81 is 3 to the 4th power, but how in the world are we going to write these with the same base? Well, be creative, okay? Watch this. First of all, 0.04 is the same thing as 4 over 100. Okay? That's the first thing you should notice. Everybody see that, okay? 0.04 is the same thing as 4 over 100. Remember, it's 4/100ths. Okay? Next. And by the way, if you struggle with decimals like that, with your calculator, just type in 0.04 and hit math, enter, enter. Now, if you do that, it's not going to give you this fraction, it's going to give it to you reduced, which is what we're going to do next anyways. So 0.04 is 4 over 100. Now reduce it. 4 goes into both of these numbers. 4 goes into 4 once, and 4 goes into 125. So now I have 1 over 25 equals 5 to the x. Hey, do you see what I'm seeing, guys? I'm getting closer here. Look, I've got a 25 and a 5. That's a little bit better. Okay? Now, I can write 25 with a base of 5, can't I? Sure I can. What's 5 times 5? 25, right? So 5 squared equals what? 25. So what can I put for this 25 right here? 5 squared. So now I have 1 over 5 squared. Do you see how I really can't teach you steps on this, okay? You're going to have to just learn to be creative and try to get common bases on both sides. Now, we're almost done. If I can simply take this 5 and bring it up top, I would no longer have a fraction. Well, guys, I can do that. We learned that before. Watch. Here's my fraction, okay? If I bring this 5 up top, what's already here? A 1, right? Bring your 5 up top, and it becomes 5 to the what? Remember how the exponent changes? Remember, if you move something from top to bottom, the sign of the exponent changes. So I can definitely bring this 5 up top as long as I change the power of the power 2 to a negative 2. Now what's left in the bottom? Nothing. Let's look at that again, guys. Come on. You got to see this, okay? Why would you bring the 5 up top, Mr. Error? Because I want to get rid of this fraction. I want to get just a base of 5. And right now I've got 1 over 5 squared. That's not going to help me a whole lot, okay? So, right now I have 1 times 5 to the negative 2 power. Well, 1 times anything will just be 5. Just itself. 1 times anything is just itself. And you really don't need to put over 1, because anything over 1 is just itself. So, 1 times 5 to the negative 2 over 1 is the same thing as 5 to the negative 2, and what does that equal? 5 to the x. So look at that. Like base, cross off your like bases. Negative 2 equals x. You're going to have to really practice these in your homework, okay? These are not easy. Alright, let's continue on. Let's try another one. Oh, so by the way, my answer was 4. So the log base 3 of 81 equals 4. Log base 5 of 0.04 equals negative 2. Now let's solve this logarithm. I don't know what it equals, so I set it equal to x. Okay, now, here's my argument. I put that all by itself. Here's my base. I put that over here as a base, 1/2. And that entire thing is to the power of what? X. So here we go, guys. It's going to be interesting. It's not going to be easy to do. I want to write both sides with the same base. Right now I have a base of 8 and a base of 1/2. Over here I had a base of 0.04. The exponent was a 1. And a base of 5. I had to rewrite this, okay? Over here I had a base of 3 and a base of 81. I had to change the 81 to a base of 3. Sometimes you have to change both sides. Okay, let's start with this 8, okay? We all know that 2 times 2 times 2 equals 8. So I know for the 8 I can put 2 to the 3rd power. So 2 to the 3rd power equals 1/2 to the x power. Okay? Everybody follow so far? Now, somehow I'm going to have to get both sides with a base of 2 or something here, okay? So here's what I recommend. I recommend we take this side here and we kind of do some work with it, okay? For example, this 2 has a power of what? In fact, if it's okay with you guys, I'm gonna make another page here. See this 1/2 right here? I'm gonna say the 2 has a power of what? 1. Is that okay? That's okay, no problem there. Now I'm gonna pick this 2 up and I'm gonna bring it. I'm gonna take this 2 and I'm gonna bring it up top. So now I have 1 times 2, but when I bring it up top, this 1 right here becomes negative. What's left in the bottom? Nothing, so I put a 1. Now, 1 times anything is just itself. And of course, 2 to the negative 1 over 1 is just 2 to the negative 1. So 1/2 equals what? 2 to the negative 1. Got it? See it? You might not have thought to have done this, but it should make sense. So 1/2 equals 2 to the negative 1. So 1/2 right here equals 2 to the negative 1. And I've still got my x here on the outside. Hey, that's looking really good now. I've got a base of 2 and a base of 2. Now, so for the 1/2, I substituted 2 to the negative 1 because 1/2 equals 2 to the negative 1. Now, whenever you have a power raised to a power, you multiply those two exponents. So negative 1 times x is negative x, or negative 1x if you want. I just prefer negative x. And over here you have 2 to the 3. And we did it, guys, look. We have like bases. Cross off your like bases and set your exponents equal. 3 equals what? Negative x. So if 3 equals negative x, then negative 3 equals what? X. We did it. So the logarithm with base 1/2, log base 1/2 of 8 equals negative 3. There it is. Wow, these could be tough, okay? Alright, one more. Log base 9 of 3, we don't know what it equals, so we set it equal to x, okay? Here's my argument, write it all by itself. Here's your base, bring it over and write it here with a base, or with a power of x. There we go. Now this one looks pretty simple, and it really is. I have a base of 3 and a base of 9. I want to write them both at the same base. Well, we all know that 3 squared equals 9. So for 9 right here, I can put what? 3 squared. But don't forget, guys, what do you still have right here? An x. Okay, because I put parentheses because you're really substituting something in for 9. And if you're substituting something in for 9, you better put parentheses around it, okay? So 9 is the same thing as 3 squared. Now, over here, we had a power raised to a power, and we multiplied those two exponents. We have a power raised to a power, so we multiply those two exponents. So now we have 3 equals 3. What's 2 times x? 2x. So students, we're done. We got matching bases. What's the power right here? Even though you can't see it, what's the power? A 1. So your bases are the same. Cross them off and set your exponents equal. 1 equals 2x. Now divide both sides by 2. And your answer is 1/2 equals x. So log base 9 of 3 equals 1/2. Okay? Well, that's half of lesson 8.2. And actually, to be honest with you, I probably should have made your heading be lesson 8.2 part 1. So if you want to write that, you probably should, okay? Because we have some more to do in lesson 8.2 later, alright? But I hope this video has been a help to you. Be sure and practice. Get a lot of practice on the homework problems, okay? If you have any questions, don't hesitate to call or email.